In this video, I want to look at an example of in-process data acquisition and then statistical process control performed on that data as it's acquired in real time. And essentially then what I want to discuss is Annex 22 as well, and the whole idea of using AI models to look at data and effectively also kind of look at the whole idea of where you can compromise the whole idea of satisfying, say, an AI budget, and then also have something that is defendable, basically at the end of the day when you're being asked questions about it. So I'll get to the punchline eventually. Basically, what I'm going to do is I'm going to just focus on a process here. Here I have a vial, it's filled, and essentially what I'm basically going to do is just run through an example, and then I'm going to shortly discuss my thoughts again on kind of Annex 22, the limitations, the restrictions of it really, and effectively kind of where we can go from there. Okay, so I have a test system here beside me. And basically what I have is data being acquired effectively in real time. We're looking in particular at fill volume of the vial as it's running through. So what I can do there is I'm just going to trigger the camera. I'm just going to put a new vial there, and I'll just trigger the camera, and basically we'll get data effectively out. And what you will have seen above there is that we have a folder where the actual raw file is coming out. So here it is. Every time the camera is triggered, we basically just have the batch ID that's there, and effectively we have the record being stored. And then in the background, what we have is we have essentially basically a SQL database that's being filled up, and that's where kind of raw data is being looked at. And what we have then is a kind of a distribution that's being done. So effectively, process engineering, one of the most fundamental items that's done is basically around a kind of a normal distribution. Okay, so essentially what I'll do there is I'll just kind of move then into the whole idea of where you actually kind of look at, say, for example, these ideas and kind of where they come from originally. So there's a book here that I'm a huge fan of, and it is called Automation, Production Systems and Computer Integrated Manufacturing. And that book essentially is very, very focused on the idea of software and then statistical manufacturing as well at the same time. So essentially the two areas that kind of give guidance here would be where you see this guy here, statistical process control. A lot of the maths is basically done in a kind of in a very raw sense. So I write my applications primarily in C#, and all of the statistics that actually come when I develop the software actually comes from this particular book. So you'll see charts that are kind of standard, like X bar charts and so on, and then you will see the kind of the classic idea of basically the bell curve. So you can kind of see it down below where you're kind of looking ahead at your process and seeing kind of where it's going and where it isn't. Okay, so I think myself most of the time when people are looking to invest in a process from an automated point of view, and especially around the term AVI, this is actually to a large extent what people are actually looking for. They want to have some kind of a predictive model that actually looks into the future. And when you are trying to validate a system like this, what you would want to do is have the software itself actually running, where you will see the bell curve actually begin to move. And then when you're doing your validation and you're writing out your test protocols, you're effectively looking at an academic text like this, and you're basically able to do an actual manual analysis on the data, and you were able to display then the raw data in the SQL database as data is being acquired in real time. So I feel that is effectively what many people are basically looking for. And I think that the whole idea, again, of the normal distribution then moving over time, where you can see something move with some form of variance in real time, that basically then you're able to defend it as being very much deterministic. So if I move across then, say, for example, to Annex 22, here's Annex 22, the core feature in Annex 22 with regards to AI, Right. So with regards to the guidance on artificial intelligence and the use of artificial intelligence, that essentially you'll see this particular sentence here. The document applies to static models, meaning that the AI model is no longer allowed to learn or no longer allowed to form its opinions. It is deterministic, set in stone, in the same way that if you effectively dive into any of the maths behind the normal distribution, that in itself is again highly deterministic. It is very, very exact. So essentially you are not gaining any benefit of the AI model. So my own opinions are that when you read this, the use of dynamic models, which continuously and automatically learn and adapt performance during use, is not covered in this document and should not be used in basically the critical GMP applications, right? So essentially, that is the key piece here to give across to everyone, that what you should do, and this is where the compromise comes in. We have our statistics here, which are built up over time, and it is all something that can be explained and laid out, whether it's in a SQL database or whether it's in a historian, whatever the setup is. And then what we do is we have our images that we have acquired here, and we can feed these to an AI model for R&D purposes, so that therefore that the actual AI model itself can form its own opinion, and that opinion can be taken into account by a process engineer over time. But having standardized applications where you have the data acquisition, which has occurred, where you're actually doing in-process monitoring, you're looking in real time for certain features, and then you're able to look at variance over time. Here I can select the time and the date, and I can kind of play around with that. I think personally myself that is what most people are looking for in the present, and that allows the actual compromise again of the AI budget, and then something that can be clearly explained and understood. Thank you very much.